Hi, grade 11. So I'm continuing with the implicit differentiation examples. Going on to example 2 now. And they're saying here, find the equation to the tangent to the curve 3x squared minus xy plus 4y squared equals 141 at this point. So we have this curve over here, this equation of a curve, and the tangent is tangent to this point here, 1, 6. So because we want to find the equation of a tangent, just remember that the formula is y is equal to mx plus c. So what I need to do first is I need to find the gradient, okay? And in order to find the gradient, I need to differentiate this equation over here. And because we've got y and y squared, we have to use implicit differentiation. So just like with the part 1 video, I'm just going to differentiate this implicitly. So this here would become 6x, product rule, so minus 1 times y. And I'm just going to put this in a bracket because of that minus. Then plus x times dy dx. Okay. Then we've got here plus 8y times dy dx equals 0. Okay, let's just multiply this negative in and we get 6x minus y minus x dy dx plus 8y dy dx. Okay, grade 11s, I'm going to take everything that's not a dy dx to this side and leave the dy dx on the left-hand side. So minus dy dx, sorry, minus x dy dx plus 8y dy dx is equal to minus 6x plus y. All right, and that's it. Take out the dy dx as common. Divide through by this. All right, now that we have the derivative, just remember that the derivative is the gradient. Okay, so that is our m value. And what we're interested in is we're interested in at this point here. And remember, a coordinate is an x value and a y value. So grade 11s, all I do is I substitute the x to be 1 and the y to be 6 in this part over here, and then I can find out what m is. Okay, so m would be equal to, and this m is from our gradient over here, minus 6 times, now our x value is 1, plus y value is 6 over minus 1 plus 8 times 6. Okay, and if we work that out on the calculator, we should get 0, I think. Let's just double check. So we've got minus 6 times 1 plus 6 minus 1 plus 8 times 6. And we get 0. Okay. So that means that our gradient is 0. So we get here y is equal to 0, x plus c. Now, in order to find the c value, I'm just going to substitute that point in 1 and 6. So we get 6 is equal to 0 times 1 plus c. So c is equal to 6. Therefore, the equation of this tangent is y is equal to 6. Okay, because that's 0 times x, 0 plus 6 is just leaving us with y is equal to 6. All right, moving on to example 3. They're asking us here, determine the equation of the tangent to the curve xy cubed plus 3 x squared equals xy plus 12 at the point minus 2, 1. Okay, so it's the equation of the tangent. Just remember the equation of a tangent is y is equal to mx plus c. In order to find the m, we need to differentiate this. Okay, so let's differentiate. This is the product rule, so it's going to be 1 times y cubed plus x 3y squared dy dx plus 6x equals 1 times y plus x, and then we've just got dy dx plus 0. Okay, dy dx is to this side, everything else to that side. So we get here 3xy squared dy dx minus x dy dx is equal to y minus y cubed minus 6x. Okay, take out the common factor. Y minus y cubed minus 6x. Divide through by the bracket. All over 3xy squared minus x. Okay, so this is our gradient function, but we're interested in a particular point, minus 2, 1. So let's figure out what the gradient is. So m will be equal to, our y value is 1, so we get 1 minus 1 cubed minus 6x is minus 2. Three times minus 2, 1 squared minus 2. All right, so if we work this out, we should get that m is equal to minus 3. All right, so y is equal to minus 3x plus c. In order to find the c value, I'm going to substitute that point in, so minus 2, 1. And we get 1 is equal to minus 3 times minus 2 plus c, that's minus 6. Take it to the other side, we get 6, we get 7. Okay, so therefore y is equal to minus 3x plus 7. Okay, and just remember that this is the gradient for the tangent. Okay, going on to example 4. It's saying here, determine the equation of the normal. So now we need to find the equation of the normal to the curve 2x cubed y plus 2y to the 4 is equal to 2 plus x to the 4 at the point 2, 1. Okay. Now, grade 11s, because we want to find the equation of the normal, all I'm going to do here is I'm going to find the gradient of the tangent. Okay. I'm not interested in finding the equation of the tangent, just the gradient of the tangent. Okay. The reason why is because, remember, you flip it, change the sign to find the gradient of the normal. So let's differentiate this. So I'm just going to leave the 2 outside, and now I'm going to differentiate these 2 here. So this gives us 3x squared y plus x cubed dy dx, then plus 8y cubed dy dx is equal to, that gives us 0, and here we get 4x cubed. All right, multiply the 2 in, 6x squared y plus 2x cubed dy dx plus 8y cubed dy dx is equal to 4x cubed. dy dx is to this side, everything else to the other side. 2x cubed dy dx plus 8y cubed dy dx equals 4x cubed minus 6x squared y, and that's it. Take out the common factor of dy dx. Then divide through by the bracket. Cool. So what I'm going to do now is I'm going to find the gradient of the tangent. So m tan is going to be equal to 4. Our x value is 2 minus 6, 2 squared times 1 over 2 cubed plus 8 times 1 cubed. Okay, so we should get a gradient of 1 over 3. Okay, therefore, the gradient of the normal will be equal to, we flip this and we get 3 and change the sign. Okay, so now we've got y is equal to minus 3x plus c. To find the c value, we plug in the point. And we get a c value of minus 6, so we get 7. Therefore, the equation of the normal is y is equal to minus 3x plus 7. Okay, last example. Determine the equation of the normal to the curve 2x squared plus 3xy is equal to 3 plus y squared at the point 1, 1. Okay, so again, we want to find the equation of the normal. So I am not interested in the equation of the tangent. I just want the gradient of the tangent. Okay, in order to find that, I need to differentiate this. So we get 4x plus, differentiate that, we're just left with 1 times y plus x dy dx is equal to 2y dy dx. Okay, so 4x is equal to plus 3y plus 3x dy dx is equal to 2y dy dx. Okay, dy dx is to this side, everything else to that side. So 3x dy dx minus 2y dy dx is equal to minus 4x minus 3y. Take out the common factor. And then divide through. Okay, so now to find the gradient of the tangent, I substitute this point in and we get minus 4 times 1 minus 3 times 1 over 3 times 1 minus 2 times 1. And we should get a gradient here of minus 5. Okay, so therefore the gradient of the normal is going to be equal to, I flip this, 1 over 5, and then I change the sign. So it becomes a positive. So we get y is equal to 1 over 5 x plus c. To find the c, plug in the point. and we get a C value of 4/5. Okay, so therefore y is equal to 1/5x plus 4/5 is the equation for the normal. All right, so grade 11s, what you can do for me now is you can do this exercise here. Okay, you can do all of that for me. Number 2, and then you can do 3 and 4 for me as well, please. Thank you.